Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at linear relations. So here we're looking at the relationship between two variables. We usually call them y and x. So I need to introduce this concept of the gradient. It is the change in y over change in x. That's what this triangle means, change in. And what makes a relationship linear is if the gradient is constant. So let me show you with, say, a table of values here. It shows the relationship between x and y. So here, x is going up by 1, y goes down by 1. Here, x goes up by 1, y goes up 1, x goes up by 1, and then y goes up by 3. So this here is a non-linear relationship. It's not linear because the gradient isn't constant. Between these 2 points, the gradient was -1, then it changed to +1 and +3. The gradient's not constant. Now, if I were to plot each of these 1, 2, 3, 4 points, they wouldn't lie in a straight line. So -1, 1 is here, 0, 0, 1, 1, and 2, 4. You can see they don't lie in a straight line. It's more like a curve. So that's why we say it's non-linear. On the other hand, if I look at this table here, the gradient is constant. Each time x is going up by 1, y is going down by 2. So we call this number -2 the gradient. It's denoted usually by m. The gradient here is -2 and it is constant. So when you have a constant gradient, these 4 points will lie in a straight line. So -1, 4 is there, 0, 2, 1, 0, and 2, -2. So all of these here lie in a straight line. That's why we call the relationship linear. So for this example here, I'm telling you that the relationship between x and y is linear, and we're going to calculate the values that go in here. So what we need to do that is calculate the gradient. So the gradient denoted m is the change in y over change in x. I'm going to use these 2 points because they're the only 2 points I have the full information. So the change in x to go from -3 to 6, I'm adding 9. The change in y to go from -10 to 8, I'm adding 18. So the gradient is change in y over change in x, which is 2. This means that each time x is going up by 1, y will go up by 2. So if x were to go up by 2, y would go up by twice that. Y would go up by 4. So this missing value here is -6. Now to go from here to here, x increases by 3, so y will increase by 3 times the gradient. 3 times 2, it will be 0. So they are the missing values. Now also, you will be asked to find a rule that links x and y. A rule is just an equation. It's an equation that tells us how to find the y value if we know the x value. So when the relationship is linear, as I'm told here, the equation is always of the form y equals mx plus b. So if I want to find a rule or equation linking x and y in this table here, I know it's going to be y equals something times x plus something. So what goes in front of x is m, the gradient. I just found that. That's 2. So I will put a 2 there. Now, what goes here, the constant that goes by itself, is the y-intercept. So that is the y value when x equals 0. So even though that's not in the table, I can easily figure it out. If I put x equals 0, I've gone up by 1, so y will go up by 2. So -6 plus 2 is -4. The y-intercept here is -4, so it goes in the second box. The equation linking x and y here is y equals 2x minus 4. If you times the x value by 2, then subtract 4 in all of these points, you will get the y value. All right, let's look at now sketching the graph of a line. So you will be given an equation like this and you will need to turn it into a graph. Now we're only looking at graphing linear relations. So that means the equation you'll be given will be in the form y equals mx plus b. M is the gradient and b is the y-intercept. So to graph, you first mark the y-intercept, you use the gradient to find a second point, and then you join the points. So to graph this one here, we need to identify the gradient and y-intercept. Now it doesn't matter the order in which things are written, the gradient is always the coefficient of the number in front of x. So the gradient here is -2/3. The y-intercept is always the number by itself, the constant. So it is 2. In order to graph this line, I am going to plot the y-intercept. That's step 1 done. Now step 2, I use the gradient to find a second point. Again, the gradient here is -2/3. It can be seen as the rise over the run. This number on the bottom is the run. It tells you how far to go across. This one tells you how far to go up or down. So if the gradient's -2/3, the run is 3. So I'm going to start at this first point I plotted, and I am going to go across 3. The run is the change in x, so we're going horizontally. X is always the horizontal axis. Now this top number tells you how far you go up or down. You go up if it's positive, down if it's negative. Well, this number's -2. So rather than going up 2, I'm going to go down 2. The rise here is -2. That means 2 down. So because I've gone 3 across and 2 down, I've ended up at this point here. All you need to graph a line is 2 points that lie on the line. So now that I've got these 2 points, step 3, I simply join them up. Now, when you're graphing, you need to put arrows on each end of a line. Unlike a line segment that has a start and end point, a line goes forever in both directions. That's what these arrows indicate. So we have now sketched the graph of this equation. On this line are all the infinitely many points where the y value is -2/3 of the x value plus 2. Every single point along this line satisfies this equation. So for example, the point 6, -2 would lie on this line, because if I substitute y for -2 and x for 6, I get a true statement. -2 does equal 2 minus 4. So any point on this line has an x and y coordinate that satisfies this equation. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.